Hello, I'm quite excited to be here to the .NET Southwest meetup. Thank you to all the speakers who are sharing the virtual floor with me. It's quite exciting so far, and I hope I can live up to that. So when I transitioned from C++ to C#, I also transitioned from Austria to Germany and had a great mentor there who taught me about test-driven development and clean code. And a good friend back then initially taught me about mutation testing, but back then I didn't care all too much about that. Now that I have transitioned now to Vienna and also a little bit obsessing myself with CI, continuous integration pipelines and workflows, I'm now trying to jam every tool there is in those pipelines. And now, since a year ago, I'm now revisiting mutation testing, and I would like to share my knowledge that I gained so far here tonight. And currently, I'm a senior dev at Admiral Sportwetten in Austria. We are having several development offices and building sport betting solution, which we're currently offering in both Germany and Austria. So in my next 15 minutes of fame, I would like to answer the question of what is mutation testing, why you may want to consider it, when to use it, perhaps also when not to use it. And if you want to use it or check it out, then how you could give it a try. So what is mutation testing? Mutation testing basically has two inputs. At one end, there'll be your production code, and on the other end, the test code. And mutation testing then looks at the production code, scans each and every statement, and when it sees a mutation, so when it can change code, basically introducing a little bug in your production code, after each small mutation, it then runs all tests, at least all impacted tests, which are those tests which are actually covering this line which has been changed or the statement which has been changed. And if there is at least one test failing, then this mutant which has been produced is killed. And this is good because that means that this line of code is not only just covered, it is also asserted with a certain assertion statement of your favorite testing library. But if there is no test covering it or even no test asserting that statement, so if no test fails after a mutation, then the mutant survives, and this is bad. And then at the end, we receive a report which then measures the effectiveness of our test suite. And the motto of mutation testing is kill all the mutants. Why would we like to apply that? I personally like it. From my point of view, it supports test-driven development in a very nice way, especially when continuously integrated. I always get feedback on how good my test suite is. So mutation testing is a way to test our unit tests. And it gives a little perspective to code coverage, since code coverage alone, viewed at it isolated, doesn't necessarily give a good picture about the quality of a code or your test suite. But in combination with effectiveness of the test suite, it gives another picture. So how is mutation testing done? So I have here a little example of the calculator. So at the top, we have our test code. So we add 1 and 2, and we expect the outcome to be 3. Below is the production code, and now mutation testing comes along and sees this add operation and mutates this. It creates a mutant, changes this into a minus operation. Now runs all the tests, or at least all impacted tests, and expects at least one test to fail. And indeed, one test is failing, which in this context now is good because a mutant has been produced and immediately been killed. And then mutation testing goes on, so the production code changes, for example, now the other way, minus to a plus, multiplication to a division. But it cannot only do just arithmetic operations, it can also handle logical or equality operations, like changing a OR to an AND, strike that, reverse it, an AND to an OR smaller than or equal to a smaller than, to just a smaller than. And then again, runs all the test and expects at least one test to fail. Mutant is killed, which is good. But there's much more mutators out there, depending on the tool that you're using. There's also, for example, here I'm now showcasing Striker. I will go into detail into this tool later on. It also supports link methods, so changing, for example, a last to a first, and then expects any test to fail. And recently, I think since 3 months ago, also supports regular expressions, which is pretty cool. So I now mentioned Striker.net, but there is more tools. Like with many projects and tools, recently there is a awesome mutation testing site. So if you want to learn more about that, give that repo to hide, and not only covers just .NET technology, but all technology, and also has some papers to read. And here are now some other tools that I checked out, like Ninja Turtles. I kind of like the name. It's the very first tool I came across, but it's like pretty old, only .NET framework. Then there is Testura, which I want to mention. This is, for example, a Visual Studio plugin. So getting in one is really straightforward. But I want to dive into Striker.net because this can be nicely integrated into CI, and this is my personal favorite. So I want to dive now into Striker.net. So since this is a global tool, we can have a look at the NuGet page, and we see this package contains the .NET global tool. So this means this is not just a library. It contains an executable that you can run via the .NET SDK, and it runs everywhere. So on your local dev machine or on the CI system. And we can either install it globally or locally. As I mentioned already, I like the local installation more because then it becomes part of the repository and gives more of a repeatable build. So it's being really part of the commit. And we can then install it and anywhere we store it. And how to use it is, I like to use it. Also supports several configuration. So you can have a look at this. So a lot of stuff can be configured. Let's actually check it out. For example, we can configure which mutations to exclude. Maybe want to exclude all string mutations, or we want to ignore several methods. For example, I like to ignore the configure await methods. I rarely have a method when I rarely have a test which asserts that changing in the production code a configure await false to a true, actually then a test would fail. I rarely have that, so I like to ignore that. But we can also set thresholds. For example, the break threshold, this is then when the CI would fail. If you want to give that a little bit more of a definition of a quality or a gateway. And now let's try it actually out. So let's see if I have it installed here. I can type .NET tool restore. And I see amongst other tools, .NET Striker is available. Now I can enter .NET Striker and I pass it in the configuration file. I like to have, the configuration can also be passed via command line, but I like to have it as a file because then, again, I can locally, but also on the CI system, then refer to the same file. So I get this repeatable build. And then I see I made a mistake, but please apologize that. What it would create now is then, for example, this HTML report, depending on the reporters that you have set also in the configuration. But there's also a plugin for the for Azure DevOps. So this major cloud provider is not down. So I can have a look at this report. It's all hosted in Azure DevOps, and it's the same HTML report that I could create locally, and then via this step upload it. And the example that I have is a little FizzBuzz application. I was recently tested by that in a job application, and so then I thought afterwards, so let's do this. I want to go a full test-driven mutation tested way. And for the example, I also excluded some tests here, and in the report, then we see what Striker did. For example, it tried to this non-empty string, changed it to an empty string, and then expected tests to fail, which then actually have been killed. For example, here we have this, changing this into an empty string was covered, but it was not asserted. So this mutant survived. And down here, the orange one is, this one is not even tested, as not even covered by the test. And then it says no coverage. And this all goes then into the report, where we see how many mutants have been found, how many mutants have been produced and actually killed, and what is the effectiveness of our test suite. And with that, I have some links if you want to go into more detail on how to install this as a global tool. I will share this all in the repo, which we'll post in the Slack in the chat afterwards. But before that, I want to give some of my personal conclusio to what I learned about how it applies to me, mutation testing. What I find good is that it perfectly complements my test-driven development, and it complements the code coverage report, gives more meaning to that. And in my experience, it worked very well with library code. And the more general purpose this library was, the more mutants have been found, and I could improve the effectiveness of my test suite. But there is of course a caveat. So looking at the mutation report standalone is perhaps not the best metric for code quality, just as looking isolated on the code coverage report would be. And to my experience, it's not the best tool to test the tests for application code, or also infrastructure as code. There is rarely any mutants there, and if there are, then it's rarely that there's actually a unit test covering that. Which brings me to a bit of the ugly parts. What we need to be aware of, that it's heavily dependent on the available mutators that the tool is having, that you're using, but also on the code, on the production code you have, on how many mutable statements there actually are. And if this isn't really a match and doesn't really go hand in hand, then there isn't a lot of mutants to produce, and maybe doesn't give so much meaning doesn't really test our unit tests. And depending on the project setup, if we have big projects with very big test suites, which may be quite expensive to run, then this entire process also takes very long. Now Striker.net, for example, supports a diff operation. So for a pull request, we could only check what the production code we fetch has been changed in this branch. But if we want to do a full one on a big project, it takes some time. That doesn't mean Striker is slow, but just this brute force of approach is depending on the test that you're having, quite slow. So if you have fast tests, and then this works very, very good.